day number 2, the end of an event that many said would not happen, but naturally it has. It's unfolding still right now, and we're going to continue with some great ideas, great resources, and with another great speaker about to hit the stage right now. But before I do that, I would like you all just to check if you have your osobno karta with you in your pocket, because somebody here certainly hasn't. Okay, I've got osobno karta here, ID card in my hand. It's from Mr. Ivan Garmaz. Ivan Garmaz. Where are you? Here he is. Ivan Garmaz. Give this guy a round of applause. Here he comes. Here he comes, slowly to the stage, as if he's a speaker. He's going to come up here and speak. Come on, come up here. You're a very tall man, Mr. Garmaz. 50 kuna. 50 kuna. Sit down. Well, there we are. Ivan Garmaz, the tallest man in Split. Right, there we are. Fantastic. Right, we move on to our next speaker, the last speaker of the day. This is actually from somebody from a gentleman who works for Five. I'm sure you're all aware of Five, one of our sponsors here as well, one of the supporters of Shift Dev, not just today, not just at this conference, but many other conferences as well. And all I'm going to say is put your hands together for Mr. Petar Marijanović.
Hi everyone, it's great to be here to talk about under this sky at this beautiful venue. So let's just deep dive. Okay. So some of the contents regarding Kotlin Mobile. So I'm going to talk about the multi-platform buzzword in general. Then I'm going to talk about, is Kotlin Mobile any different than the multi-platform technologies that currently exist there. Then I will talk about the first initial idea that we took with Kotlin multi-platform, actually Kotlin Mobile. I should call it Kotlin Mobile. It renamed itself to Kotlin Mobile pretty recently. So the first idea didn't go really well, so there's our take on it too, 5 days try back. And at the end, I'll talk about summary and some of our next steps. So why me? Why should I talk about Kotlin multi-platform? Actually, Kotlin Mobile again. So I developed and delivered an application already built on Google's J2 Objective-C library. I'm a Kotlin early adapter. I was using Kotlin even before Google announced it as the official programming language for Android development. And I currently work at Five, which is a Google Developer Certified Agency in 2018. Google basically said that we know how to develop Android applications. And some of our bigger clients are Rosetta Stone, Napster, Game of Thrones, Marriott Hotels, and Crestron Electronics. So enough bragging. So let's talk about the multi-platform buzzword. So the general vision regarding every multi-platform technology that is currently out there is that you write code once and you run it everywhere. That's the general vision. There are drawbacks regarding it, but this is the main purpose of a multi-platform environment. So what does that actually mean? It means faster development, which in return means you need to write less code, which then implies that it's the lower cost of the project, and the return of investment is bigger. So current multi-platform business drawbacks that exist out there with the current technology is, for example, product experience. Users like the native user experience and performance, which you can't have with some of the current technology that's out there, which is running their own engine on the mobile device. There are also API restrictions. For example, some of the technology couldn't utilize platform APIs that you want to use, so maybe competitors will have that experience if they develop their applications natively. Also, update cycle, users are eager to get the latest tech, and everything new that comes out there, it first needs to be wrapped inside of the multi-platform library. Then you can use it. Maybe it can take a week or it can take a month. But users want to use the native and latest tech on the mobile platforms that they are using. and also price. Some of the technologies out there are not free. So those were the business drawbacks. Here are some of the tech drawbacks. So there always is a learning curve. So it's either a new language or a new concept, or the support is smaller. You can't Google almost everything that you can for native development. That is also another layer of issues, because both platforms are not perfect. They have their own bugs, and you use a new multi-platform library, which also has their own bugs. So you just need to mingle in between those bugs to make your product work great. And also finding new developers is really hard, because you no longer need only cross-platform developers, you also need native developers. So your cross-platform developers should know both Android and iOS for the application to work properly. Those are really hard to find. Okay, so that's about the multi-platform buzzword. So is Kotlin Mobile any different than that? Okay, another slide with the same question, and yes, it is. It's conceptually different. So I took an example here. This is example of React Native, and under the hood it looks something like this. You start from multi-platform code. You write only multi-platform code, and then that multi-platform code, which is actually written in JavaScript, is run on a separate engine inside of the Android and iOS applications. And if you want to talk to platform specifics, you need to create bridges, which sometimes can be difficult, and that's the way to communicate with the platform, with the native platform. Also, with new versions of the multi-platform technologies, that building bridges can break, so you need to just redo most of the stuff. Why is Kotlin Mobile different? Because I like to think of it like this way. So you write both native Android and iOS applications. You need both developers to work on the project. That native Android or native iOS application talks to native Android library or native Android framework, which is built from the Kotlin Mobile code. So it's basically everything is native, and we'll see how under the hood, how does it work under the hood. So how does it look like under the hood? So most of the people when they talk about Kotlin, they actually talk about Kotlin JVM, but not many people know that there actually are 3 different flavors of Kotlin. There's Kotlin JVM, Kotlin Native, and Kotlin JavaScript. So when we talk about Kotlin, at least in the Android world, we talk about Kotlin JVM, which compiles down to Java bytecode, which runs on the JVM machine, JVM runtime, and you develop Android applications. You can develop server applications or desktop applications. Kotlin Native, on the other hand, compiles down to machine code, and you can run it on iOS devices, desktop applications, WebAssembly, or even Android, for example, some Android games. And there's also Kotlin JavaScript, which Kotlin compiles down to JavaScript, which you can use on web and cloud. We won't talk much about Kotlin JavaScript. We'll just talk about Kotlin JVM and Kotlin Native. So these were our predictions. So if you need 100% of the time, effort, money, developers to develop two actually the same native applications, then you need 50% of the time to write a React Native application, and Kotlin Mobile is somewhere in between, and it takes like 75% of everything. This was our prediction. We'll see where we got after that. So I talked about the current tech drawbacks regarding all multi-platform technologies. Let's compare them to Kotlin Mobile. So product experience, we said that on some technologies we compromise native user experience and performance. Well, since Kotlin Native compiles down to Kotlin Mobile compiles down to native binaries, we actually have native performance. For API restrictions, we weren't utilizing full platform potential. We can easily leverage all available platform APIs. Exactly like the update cycle, we can leverage them immediately. So as soon as the platform supports it, you can also support it. Regarding the learning curve, it's still applicable. A concept is different, and we'll go a little bit deeper regarding the concept, but also the support is much smaller than on the native experience. There is another layer of issues, also still applicable, but easier to avoid. What do I mean when I said it's easier to avoid? Because you can you decide what you want to reuse. If there is a Kotlin Mobile bug and you just can't get around it, you can simply just write it natively on both on Android and iOS, and once the Kotlin Mobile bug is fixed, you can write it in the shared module, and everything will be shared again. And finding developers, there was a huge sentence with finding developers, but I just written down hard, so it's no longer hard. Basically, any native mobile developer can start writing Kotlin mobile code. You just need some time to get accommodated to it. And price is free. So let's talk about our take on it. So the backstory is that we noticed a lot of hype around Kotlin mobile, and we have a R&D team in 5. So we decided to build a proof of concept on top of Kotlin Mobile. And the team was me and 2 other really senior mobile developers, which are currently in the first row here sitting. So we got a new client, which wanted a smaller project, both Android, iOS, and backend, and we wanted to use Kotlin everywhere. So we also took, for the tech stack for the backend, we choose Spring, and we've written Kotlin also there. But let's not talk about that. It was successful, but the other part wasn't. So let's talk about Android and iOS. So also, I took a bet with myself that I'll take myself to dinner if I succeed. Stay tuned if I did. OK. So our take on it. In 5, we use reactive clean architecture. So what does that mean? We have our application divided in multiple layers. The first one is the UI. Below that is a presentation layer, use case layer, data layer, and entity layer. On the UI layer for Android, we use fragments. For iOS, we use view controllers. Then we communicate with view models, and we, for example, have use cases. We have a command use case, which modifies the current application state, and we have a query use case, which listens to that state. We also have, in the data layer, we have repositories, services, sources, and so on. We never wanted to compromise on the UX UI, so we didn't want to reuse anything on the UI layer. We wanted for our application to be as native as possible for the user. So we decided to take baby steps. Since we were new in the Kotlin mobile world, we didn't want to reuse everything. We wanted just to reuse the business logic. We wanted only to reuse the pure functions. Pure functions are functions that don't modify state and always for the same input produce the same output. And also, we didn't want to use any external libraries. We wanted our risk to be as minimum as possible. We just wanted to learn about the tech. Also, we kept in mind that our developers, that we will hardly find any Kotlin mobile developers, so finding them will be an issue. If we find any mobile developers or our current developers, it will take a long time for them to get up to speed with the development. And also, we wanted our developers to stay up to speed with native platforms. So what does that mean? So for example, if you're an Android developer, we wanted our Android developers to always use current Android libraries that are out there, so they're always up to date with the Android development. There are Android developers for a reason, and we didn't want to force them in the Kotlin multi-platform environment. Kotlin mobile, sorry, I always say Kotlin multi-platform. So why did we learn? This is a really odd sentence because it's actually should say why did we fail, but each time we fail, we actually learn something, so why did we learn? So this is a mouthful. So we learned because of our lack of knowledge about the huge memory model difference between 2 runtimes that should coexist in a multi-platform environment. I actually written this, and it's really hard to understand. But the biggest problem here is there were multiple problems, but the biggest problem here was that there was a different memory management model. So what does that mean? On Kotlin JVM, there's a relaxed memory management model. That's how they call it. And that's the memory management model that you all know and you all like. So you can basically share an object between threads and everything should work. It's on you to take care of race conditions or deadlocks and so on. But if you're a senior developer, you should know how to do it. But on Kotlin Native, and this is something that we didn't know, is they have a strict memory management model, which is strict rules around how state is shared between threads. Under the hood, the runtime ensures that there are no race conditions or deadlocks, and garbage collection is fast and easy. That sounds really great, but how do they ensure it? They basically crash at runtime if you try to share an object between two threads. If you don't know about it, you just get an ambiguous error, and you don't know what the problem is. Also, Kotlin native threading didn't work properly with the current state of Kotlin coroutines. Since we are using Kotlin, we wanted to use Kotlin coroutines for our concurrency, and at the time, Kotlin native threading didn't work properly with it. That's the second problem. The third problem is that we had a lot of issues with generics. Okay, yeah, Kotlin Native generics can only be defined in classes and not on interfaces, protocols, or functions. We didn't know about it, so that also was a problem. Well, yeah, the problem is that we developed a proof of concept, but we didn't dig deep enough, and that was our mistake. So how did this affect us? Well, something like this. This is a long GIF. Okay. So our take on it. So I started working on it. Since I'm an Android developer, I know the Kotlin JVM runtime really well, so I made it work, then made it pretty on Kotlin JVM. I expected it to work the same on Kotlin Native, but it didn't. So I desperately tried to make it work with the current code base, and I learned. Great. Okay, so we needed to take a second step, second take on it. How did the second take look like? So I took a step back. I dug deep into Kotlin Native memory management model. It took about 2 weeks to learn about everything, to know about the nitty-gritty details, but I managed to do it. I made it work, then made it with the help of my 2 best friends there. I made it work, then made it pretty on Kotlin Native. And once it works on Kotlin Native, it also works on Kotlin JVM. So since Kotlin Native is strict and Kotlin JVM is relaxed, whatever you write on Kotlin JVM, everything works. If it's compliant with the Kotlin Native, then great. And then I learned and succeeded at the same time. Okay, so our take on it too, we needed to take a different approach. As I said before, we noticed that the biggest issue was jumping between shared and native code. So we ditched the baby steps approach and went all in. And we reused everything except the UI layer. So everything inside of this white box is reused. Our calculations that we reused around 80% of the code base. The second detail that we noticed is that, yeah, as I said before, Kotlin coroutines don't work great on the iOS platform. So we made an architecture which basically takes care of threading for us. The main thread is located on the UI layer, and everything else is run on the background layer. Yeah, it sounds like it's straightforward. It sounds like that's the way to use it, but it was kind of hard to do it on Kotlin mobile environment. But we managed to do it. So our architecture takes care of everything. So any new developer doesn't need to know about it. It just uses our APIs, and everything should work. Yeah, threading on iOS still didn't work properly, but we made everything in place. So when they fix the issue, we should just update the library and everything should work. And the last thing that we had a problem is generics. So there wasn't a simple solution that fits every purpose. So we just made the most of it. So what can we use and where? We use different solutions for different situations, and there is also a mechanism called expected and actual mechanism on Kotlin multi-platform, which is a new mechanism that I learned while using Kotlin multi-platform, Kotlin Native, Kotlin mobile, and it's a really strong and really powerful mechanism to use. I won't go into details, but if someone wants to develop a Kotlin mobile application, just keep in mind that you can use generics with the expected actual mechanism. So before we had these predictions, and then we just figured out that it actually depends. So we decided to use almost everything. That's why we used 80%. But if someone has a different architecture, he can maybe reuse only one function inside of the Kotlin mobile environment. So his percent will be much lower than ours. So this is actually great about Kotlin mobile, which you can actually choose what you want to reuse and how to reuse it. Okay, and lastly, it's the summary. So here are some of the things that, again, if someone wants to jump in the Kotlin mobile world, here is something that you should remember. So there exists a Kotlin native strict memory management model. A great thing is that I, for example, use Twitter, which I got an impression that no longer anyone uses, but some developers still use it, and some Kotlin native developers written on Twitter that they are going to ditch the Kotlin native environment for Kotlin native strict memory management model for the Kotlin mobile, and then we will have the Kotlin JVM relaxed runtime. At the runtime, the memory management model. Also, Kotlin native plus Kotlin coroutines is not quite there yet. They made an improvement. Before, you can only use the main thread. Now, they made a small step forward, and they added one background thread. So you can use, on iOS, you can use main thread and one background thread, and that's why I said it's not quite there yet, but it's going somewhere. Be careful with generics, use expect and actual mechanisms, and dig deeper with implementing proof of concept. This is actually a sentence for me, so I can remember it in the future. Regarding our future works, so we didn't want to use any dependency injection framework at the time. Now Coin supports Kotlin Mobile, so we will migrate to Kotlin Mobile. We've written our own library for it. We had an idea. We had an idea about how to mitigate the Kotlin Native strict memory management model, and this is also a mouthful, and this is not my idea about naming, but it's called thread memory bound object scoping. This is just an idea how to mitigate some of the problems that we have with the Kotlin strict memory management model, and maybe we won't even need to use it if they will ditch this approach. And we also want to make everything open source. So it's currently still a work in the progress. Once we make it so it's like version 1.0, we will make it open source so everyone can see what we've done and contribute to it also. And regarding the bet, I took myself to dinner because I learned again. Okay, that's pretty much it. Do you have any questions? No questions. Okay, I didn't know about that. So thank you.